So, good morning and good afternoon to welcome back to this new series. Today we are talking about the automatic geosteering system using closed loop drilling controls and real-time petrophysical modeling. So, I am Matteo Mirabiglio from Geologists from Frugo and SLB. I'm very welcome to present you some news about this advanced technique. We have specific new tools that we are improving in this case. So the principal topic is regarding the new tools, the MVD tools Pulsar Star, the automatic geosteering tools cased in using closed geothermal wells, automatic geosteering closed in advanced condensate gas, the implementing geosteering with loops drilling controls, and we have also the Bogota case history. So this is a new webinar series, and today we are talking about this kind of webinars. We can use the different tools for the geosteering projects, and we have especially some new geosteering projects, and we want to underline specific characteristic of these tools. We have, for example, the new tools that we have projected for the Slumberger, and we have a principal resume of trouble of these new tools that is represented from new tools are analyzing, and in this case we have the tomography, and we have also the analysis of radar directional radius. We have telemetry breakdown, the measure failure categories, that is project to resolve the classical MVD tools is the telemetry breakdown, the environmental stress, the mechanical failure, and we have also other kinds of this. So we want to underline especially the new performance of these tools, and you have these types of series. So you have several types of this, and in this webinar we can underline the new tools called MVD Pulsar Star, and the principal trouble for the standard tools is the component machine failure and like this. So telemetry solution for we built a new telemetry solution for high temperature and high vibration systems. It regards the essential of characteristics of new MVD Pulsar Star. So analysis of extreme environment condition, vibration induced for data loss, thermal signature, MVD Pulsar Star. And we have also the principal signature of this. So you have several applications of these tools, like for example geothermal project or advanced. We have an advanced rope inclinometer sensor, an emerging MVD technologies, and we have advanced rated of penetration rope. High precision multiple inclinometer and azimuth sensor. We have an emerging MVD technologies, and we have a sensor of MVD Pulsar Star. So the well bore content is the must. The new MVD Pulsar Star and sector application. We have several applications for real-time decoding, survival of 250 gram shock, extended activity operation environment, high bandwidth and telemetry fusion. So this new system of telemetry guarantees high efficiency and low latency times. The wellbore content, we have the active deep water operation with the high pressure and temperature, extended traction and complex trajectory, and we have optimized drilling efficiency and rope cost. So the performance is the validation of performance in complex geological application. You can see this validation in the Bogota field, the test validation in ultra resistant water vibration and stock tolerance, So you can have this, for example, in this kind of application, and you have also this, for example, when you have a fault, you can see this. So this is a brief presentation of new tools, and we have just to do this for the MEVD Pulsar Star, and you have the new tools that is also designed for Frugo for acquiring download data in compact claystone situation. We have the miniaturized and developing for offshore CPT, and so these events want to make also a presentation of these new tools makes for Frugo and SLB, but underline also a new approach for automatic geosteering system using closed loop drilling. And the major advantages of mini Pulsar Star for CPT deployments is the miniaturization and fit, the reliability, the vibration tolerance, the data feedability and telemetry, the integration fusion, and you have also to some others advanced. Is really proved to do these kinds of operation, and automatic geosteering case in using closed loop. This first application in basin in Germany basin. This is a geothermal well steering automation process and casing application. We have the performance of metric application with the rapid decision and response instead of the traditional manual process for geothermal data acquiring. And we can apply this process also in open casing with measure advances and in case hold, in closed case hole in geothermal formation. Case hole means when you are cementing the formation and isolated the steam power. So the high closed loop geothermal process enhance and reduce the cost of time around 20%. You have several applications with times delayed, data acquisition and decision tree. We have developing a specific decision tree, decision speed and response, manual decision speed, automated decision tree, human interview and bias. We reduce this. We have high loop steering and minimal tortuosity, so the support to reduce the minimal tortuosity and these strategies. This is a key patented for the Sumulge. Resume application of automatic decision tree to geothermal exploration. You have this for an automatic decision tree system for wellbore application strategy and like this. Go fast. What does it mean automatic decision tree? Decision is revolutionizing the drilling and change the whole approach from reactive to proactive behavior. So decision tree with automatic geosteering closed loop change the approach of drilling operation to proactive to reactive to proactive operation. Reduced all optimized well placement from between the 12 to 30%, reduced drilling days of 20%, have an increase of security, and total operation cost savings around this value for projects. You have several approaches, close advance instead the geological hazard after well drilling bit, passed through reactive to delay to this 1 hour to 12 hours medium prevision, and immediate tools loop for this value. It's clear that we have several applications also in gas condensate exploration. You have the same application from reactive to proactive, and the critical challenge why traditional geosteering unperform in condensate gas. For example, you have a great application in gas field of Bogota for unconventional gas exploration, because the classical geosteering we have a condensate gas reservoir geological sometimes is a complex phase behavior and management. So this operation consequence and value increase drilling cost, poor F times operation like this. So to proactive engine, machine learning models are mapping common geology in 1 to 2 hours to 12 hours in advance to automatically adjust steerable system before hazards are encountered. So reactive looks its scope, real-time integration of like seismic data, LVD and new mini LVD, MVD tools, flying and downhole pressure. So we have the operation closed loop established through the boundaries for automation, approach and auto steering. Several parameters are reconducted to one single models with optimizable board and also geomechanical stability. So you optimize the rate of rope from 12 to 30% using total drilling times lines in this case, impact on total cost of capex and long-term production security field. Workflow immediating geosteering loops. You have a briefing of design of implementing geosteering loops with controls. So you have data integration, real-time application, and like this. Go fast, compare table, traditional geosteering versus high closed loop geosteering. High closed loop geosteering guarantee a proactive approach and real-time customization. Data integrate, phase optimized, and executed instantly in milliseconds. So the data-driven and automated deterministic algorithm performs 24 hours, 7 days on 7 days, eliminated all overcorrection, fully integrated subsurface AI, and maximize paid zone contact. The drill complex path automatically for also different projects like geothermal or hydrogen, drastic NSPT productive time reduction. Implementing a geosteering advanced real-time integrated for proactive closed-loop drilling. You have, for example, the assessment of pre-drilling seismic and live update during drilling with living and real position and displacements of fault and real rejected of different thickness of layers. So you have also all of types of logs, gamma ray, resistivity logs, deep directional, and like this we have the dynamic surface parameter integration, WOB, surface torque with data convergence, for example geology, geomechanics, drilling parameters, closed-side loop and trajectory, and the trajectory update only 20 minutes. The auto-regulation closed loop have several optimization, for example, to manage pressure, temperature, or also for driving around the fault, or so, for example, for wellbore smoothness optimization engine. You have a micro branch, high sensitivity, eliminate all kind of tortuosity and microscope challenge and data analysis. This is a brief of closed loop for wellbore geomechanical stability. Avoid all kind of geomechanical failure during the drilling is one of the must of application of new measurement-wide drilling tools and loop with geosteering projects. The traditional, we have an unmanaged stability. We can prevent all kind of collapse. We manage a stable path and like this. So reduce geomechanical risk, in SPT, enhance the security of project, enhance completion and fracture placement, improve completion running, accuracy of hydraulic fracture is the second step and target of applying automatic geosteering with using closed loop drilling controls. Maximize asset value and like this. You have a security, you have increased security hazard avoid with advanced closed loop geosteering. Avoid all of mechanical failure, avoid the explosion for gas bubbling, like kick or nothing of dangerous gas, avoid the risk for heat flow crunch, enhance completion and frac design, and maximize asset and value by euros. This is a clear interpretation of integrated physical data with gas chromatography in Bogota Basin. So the Bogota Basin is several millions, around 50 millions ago developed, just filled by sedimentary basin, and you have disintegrated geosteering is used in this case, and the integration of gas chromatography for reset target in gas exploration in Bogota Basin. You have this kind of alternative lithology, recorded the porosity, we have the gas indicator, move up with high grow content in shale zone. The target zone is this in arenaceous sediments. We have also the initial target trajectory that was finally established by first seismic data. By the results of automatic geosteering, we have corrected and reduced the total trajectory of 20% and go directly to the target. Integrated interpretation of logs in Bogota. We have a clear example of integrated interpretation in logs in Bogota. So you have this shale, gas shale, water caps and gas. So we have several lithologies like sandstone, siltstone, shale and coal. With log response we have these kinds of guides. We want to present the new sensor developed for Schlumberger. The new sensor developed for Schlumberger is called the miniature gas bubble sensing. We are installing this in the final stage of project in Bogota. In the final stage of project in Bogota, we have several gas that have a confluence in area of captation. Some of gas can be mixture and reduce the quality of methane gas. So we are monitoring the geochemical composition, new miniature gas sensor bubble downhole composition monitoring. So we can set of gas, we can monitor the methane data, the carbon dioxide, the hydrogen sulfur, the oxygen, and the pressure and temperature. So this is a very small sites with able to work with with different temperature in housing material in called titanium, and the data transmission is real time with the telemetry. This is the kind of application that are field testing, field developing of Bogota. System of alert for gas presence like periculous gas or explosion gas like helium or hydrogen or like this. You have set the system of alert. We have recording all of the time and monitoring the presence of periculous gas or gas that contaminated the extraction. So this is a scheme of deployment view through the downhole gas sensor that was developed for Schlumberger. Thanks for attention, and thanks for Schlumberger and for Frugal for sharing the basic data and an example of application.